Now remember that Ohm's law gives us a relation between the voltage and the current in a resistor. Okay, so usually Ohm's law is written in this way. E is equal to I times R. Or in other words, the source voltage is equal to the current through the resistor times the resistance. You could also write it as V is equal to IR, where V stands for the voltage, of course. So as an example, we have the voltage across a 6 kilo ohm resistor is 18 volts. Find the current. Okay, so we're asked to find the current, so let's start with Ohm's law in the form that it's given and solve this equation for the current. Okay, so current is represented by the letter I. So to get the current by itself, I need to divide by R, don't I? So I go V divided by R is equal to IR divided by R, divided on each side by the same quantity R. Okay, the R's here cancel, and so that means that I is equal to V over R. Okay, easy enough. And now we just need to fill in the values. V is 18 volts, 18, and R is 6 kilo ohms, 6K, and of course that K represents the multiplier times 10 to the third, right? So 18 divided by 6 times 10 to the third. Of course, you know this calculator shorthand for times 10 to the power, which follows, letter E. And the answer is 3 milliamps. You see this times 10 here, and then raised to the power negative 3. That gives us an answer in milliamps. Okay, now we also have looked at the situation where resistors are connected in series. And in the case where resistors are hooked in series, then to get the equivalent resistance, we just need to add the resistors that are connected in series. Okay, so here's an example. A simple circuit with two resistors hooked in series and a voltage source. And we want to find the current. Okay, so the way we do this is first find the equivalent resistance. So total resistance is R1 plus R2, 3 plus 12, or 15 kilo ohms. Okay, and our voltage is 5 volts, so we have I is equal to V over RT, 5 divided by 15K. The answer is approximately 0.33 milliamps. Okay, and the solution is sketched out here in the notes.